Okay, so we have a lot to cover in 35 minutes, and because the live demo is the most important and coolest part, I'm going to breeze through the beginning, but I figured if we're going to talk about edge computing is not just hype, we should also cover a little bit of the hype first. So we'll do that. My name's Kilton Hopkins. I'm a co-founder and CEO of a company called Edgeworx, and Edgeworx is the core maintainer at this time of the Eclipse ioFog project. And I was the original, the creator of the Eclipse ioFog project and the original architect, still the architect, but now, I need smarter people than me, so we have people from all different kinds of companies helping, grow it, maintain it, and so on. So turning on the remote is a good idea. Great. So what's the hype? Edge computing is supposed to be a mega trend. Big data was a megatrend, cloud computing was and still is a megatrend. It just means that we're going to be spending a lot of time, and a lot of different companies are going to put effort into making edge computing come to life. Why? What's the big deal? What's the hype all about? Well, the biggest problem here is that the sources of data are increasing. And we all know this with IoT. That part's obvious at this point. But IoT sensors are not just the only source of data coming from the edge. We have, for a long time, had sources of data in intelligent factories and in operational facilities like oil and gas refineries and so on. And not all of it is IoT data. And we are finally trying to address the problem of data separation, where it lives in one place and it never really merges with the rest of IT systems. If you're going to make the operational world, the physical world, collide with IT, then that means that we're going to have sources of data into our IT systems that are just massive and growing all the time, and they contain data types that we're going to look at today, like video, that are incredibly difficult to stream up to the cloud and manage there. And the market size is supposed to be huge, all of these usual slides. Well, I'm going to prove to you that the hype cycle is somewhat real, and that it's actually begun today by looking through a customer use case. So in order to address edge computing, we need to think what emerged from cloud computing that allowed it to grow and stabilize. And one of the things that emerged was DevOps. If it wasn't for developer operations, we would not have the cloud operating the way it does today. Super important to us. Well, those lessons are still valid, but we need to move them down into IoT and edge systems and do what we call edge ops. Otherwise, we're going to end up with this really terrible growing pains period in which things get worse before they get better. Well, we've already learned the lesson, so let's try to take what we know from here and move it on down. And the edge ops, the IT OT conversion will not happen without edge ops. That's kind of the key takeaway. So what's the edge computing situation? This is the obvious part. Like, if you've looked at all that edge computing, someone has probably said something similar to this, which is we have a centralized infrastructure that we built for the cloud, and it's now time to spread out again, and that we've done this before, right? We go centralized, decentralized, back and forth. Well, the distributed era that we're entering is different than the prior ones, evidenced by the graphics. We don't have a single point of compute with a keyboard and a monitor and a mouse, and that's what our edge is limited to. Our edge is hundreds, thousands, maybe even millions of nodes that we have to contend with. So it's different infrastructure, just the same as the cloud is not one big mainframe to babysit, but a huge collection of resources that makes the cloud. So call this the numerous distributed or numerous decentralized. It's a different problem. And what happens at the edge that makes it so weird, why edge computing is a thing? Why don't we just do cloud computing on premise, right? Or cloud computing in the car? It's because edge environments have connectivity problems that are really bad. And in fact, this is actually what it looks like in West Texas in the United States, or in Southern California, where we have the oil and gas wells. You have a site that is trying to get some limited bandwidth out to the region, and that's your only pipeline of data. There is no way to increase that. So you have to do as much on-premise or at the wellheads as you can. And in the cloud, it's almost infinite, right? Connectivity is not our problem in the cloud. Within the cloud and data center environment, connectivity is fantastic. And at the edge, it goes offline all the time. The hardware in the cloud is well established. It's homogenized stuff, right? When was the last time you wrote code and then you asked your server administrator to give you a server and then asked, are you sure it will run this version of Python, right? Those days are long gone. But at the edge, you have this heterogeneous hardware. Everything out there looks different. The pump controller on these is different than the GPU-enabled compute that's in an autonomous vehicle, which is different than the the special FPGA in a camera that's doing video encoding, and yet you have to address all of them. Power is also a problem. So you don't have to worry about this in the data center. In fact, data centers are located close to huge sources of power so they can get the cost benefits of being located near the generation of power. And out at the edge, you might be running on a battery that's charged by a solar panel. And that means that you can't discharge the battery more than 50% in any given use cycle, any given day. And so that sucks. And then security. So security is actually one of my biggest concerns about the edge because it's rarely talked about. But you can't go into a data center and just go up to the front desk and say, "Hi, I'm a customer. I use one of these servers in here. Can you show me where it is?" And then they're, "Oh yeah, go right this way. It's down this hall to your left." You won't even get past the front desk. You might not even get to a front desk. And yet at the edge, somebody can walk up with a ladder and a screwdriver, take the camera down from the corner of the building, take it home, and do whatever they want with it to try to get into your system. Physical security is completely broken down at the edge. And yet all of our public key infrastructure and our private public key pairs and things, they're all geared around the notion that the physical compute is protected, so nobody can get that private key physically, so then you have to protect it via software. The software protections are fine, but the physical isn't, so you have to think about it differently. In fact, I'm so concerned about it that we have this working group at the CNCF. It's called the Kubernetes IoT Edge Working Group. It was actually started by Dejan Bosanek from Red Hat, who is here at the conference, and many of you probably know. He's an awesome guy. Dejan started this working group. He invited me and other Eclipse-related folks in, and then we wrote this paper called Edge Security Challenges that the CNCF recently published. It's basically just a paper that talks about all of the awful stuff with regard to security that we have to contend with at the edge, and kind of why is nobody talking about this. So if anybody wants it, I can send you a link to that paper, or you can just go to the CNCF site and go to blog, and then or newsroom blog or whatever, and you'll see it in there. But anyway, there's a lot to read about security at the edge. So let's talk about the technology briefly, and then we'll dive into the live demo. What we're aiming for is to take the cloud and extend it to the edge. It doesn't do a lot of good to have a specialized edge because nobody has the skills for it. And these days, when you tell somebody that you need to program, like for this board, you need to program in this particular language with this particular skill set, unless that's the most popular board ever, or they're being paid by their boss to do it, people won't learn that language. They won't learn that skill set. It's a bad bet. It's like saying, would you bet your career on Rust or Golang? Why do you have to choose one, right? You definitely would not want to say, I will go on one and never the other. But when you build for specific edge hardware, often you're making a big investment in something that you don't know is going to pay off. But if we extend the cloud down, and your same skills apply to the edge, to all of the edge boards, then who cares? I'll dive in, I'll do some edge stuff because it doesn't hurt my career. It's the same stuff I use in the cloud, right? It's what we're aiming for. And you should manage the edge just like you manage the cloud. So there are a couple of patterns that make edge computing come to life. The basic one is making everything intelligent. So when someone says you need to be able to run containers at the edge, that's this, making the edge intelligent, right? Give more software down close to the source of data. But that's kind of like just the first piece. If you can do that, then that's a great experiment, but you can't really go into production with just that. You need to also make it managed. Because the cloud is the same way. If you had one server that was tethered by an Ethernet cable to your desktop environment and you put code into that, you could manage that server, no problem. You'd babysit it all day, no big deal. If it goes down, you bring it up. Multiply that by 1,000. Then you need an entire department, whatever. So you start saying, we don't need people managing this, we need manageable infrastructure. And that's how the data center grew to become much more manageable. We got hypervisors in place and all of this stuff. At the edge, we need the same thing. If you have 10,000 vehicles in a fleet and you need to manage a rollout of a software version change for a particular microservice on all 10,000 vehicles, you're not driving them back into the station to get that update. You have to be able to push a button and deploy that, or have it scripted when the build completes and all the tests pass. That's the right way to be deploying to the edge, so it has to be as manageable as the cloud. And then we need to make everything connected. Most of the time when people talk about edge stuff or IoT stuff, they say we need to make it connected, and what they mean is we need to give it an internet connection. Give it Wi-Fi, give it a cellular connection, give it a LoRaWAN connection that goes to a base station that goes to the cloud. But what they're talking about is taking whatever happens at the edge and piping it up to the cloud somewhere. There's probably a REST API that it hits and posts the data. That's not what edge connectivity is all about. Edge connectivity is edge to cloud, cloud back down to edge. That's dangerous, but it can be done, and edge to edge. Because if I take the video off of a camera, like the one I have in this room, and I want to send it over to another processing unit that's down the hall that has a GPU and can do AI on the camera, if it has to go to the cloud and back, then I haven't solved a problem. Well, not a connectivity problem. I might have solved an edge hardware problem, but it still has to pipe around. This needs to be able to send it over the LAN over there. But now I shouldn't be wiring cables everywhere either, so how do you make that manageable, of how to make things talk together? Well, it just so happens that software overlay networks, what we call an edge compute network, is probably the right architectural pattern for this. It makes it possible for you to use a software layer that's focused on the application to send the data logically, and physically it gets handled underneath by cellular to the base station, which then goes back out on fiber to the data center and talks there, but it never really touches the internet. And so that abstraction is a key part of edge computing infrastructure. And then, of course, secure. I'm going to give a brief example of how to do this better. So I was an IoT advisor to the city of San Francisco. And while I was there, we got hacked. We got hacked really bad. Somebody went on to a San Francisco Muni bus, which is like, just think like a city bus, and they took a little CAN bus processing box off the bus. That box has been there for years, and it had VPN information, because how else are you going to talk to the vehicle? And then it also had a private key, because how else are you going to identify the vehicle, right? Just use a private key, just like we do for cloud servers. They took that information, they got into the back end. We think they were there for probably 2 months before they did anything. And when they finally did something, they shut down bus terminals and train terminals. They posted up on the overhead sign, instead of the next train will arrive in 5 minutes, it said send 50,000 in Bitcoin to this address. It was not a good day. It was not a good day. So they posted their email address, though, because that's where they wanted us to communicate with them, maybe negotiate. We didn't talk to them. The press did. They wrote, said, how's it going? You got your ransom yet? And the person replied, not yet, but I'm confident. While this is happening, there was a commuter who was a nice hacker, a white hat hacker. They recognized the email address from the dark web, and they recognized that this person also was doing this in other places. They got into their email account. They hacked their email account. They locked them out. They sent a message to them, a forwarded message to their other address that said, next time pick a different city. Because it's true. If you're going to hack a city, why San Francisco? Why any other city, right? So they never got their Bitcoin ransom. We had to flush out all the keys so that every bus went offline, right? All of these things. But finally, we got them weeded out. But the damage in terms of the commuters losing their commute time and stuff was done, and the public image was lost already. People were mad at us. Here's what I learned. If you take a fixed identity and you put it into edge hardware and put it out in the world, it's like taking your house keys, putting them on a park bench and walking away. And they have a tag on them with your address. So basically saying, come and get it, right? Come rob me. That's what it's like to put a private key, a fixed private key out on hardware. Instead, you need keys that are generated based on something that you can attest, like the hardware root of trust to say the board is the same, secure boot to say nobody's tampered with it, and then you need something to attest that the microservices running on it are the ones that are supposed to be running, and that nothing else is happening. If you put all that together, that's a better identity than just some string of numbers, right? Because somebody can get that, and then it's just like a password to your backend. So to do all of that on the edge hardware, we have this thing called ioFog agent. And this is a piece of software that sits on, well, this board or any board. The whole idea is that you pick the hardware. It can be anything. I have a Raspberry Pi here because they're cheap, they work, and other people can do it too, so it's a great thing to bring to a conference. What we do here with the agent is we abstract the hardware, we put some protections in place, we check some security things, and then we provide a set of APIs that you can interface with, and then we talk to the control plane, and only the control plane, to do our business, so that way if somebody tries to run a container locally, we'll actually shut it down as soon as we detect that something's happening. And only containers that are sanctioned by your control plane commands are run. So we'll have to breeze through. I can go deeper, way deeper in all this, but I think in the interest of time, let's get to the good stuff. Above a single node, you have this edge compute network concept. And that's where you get into tools like the control plane, and you have this thing called ECN Viewer, which we'll look at today, which shows you your edge compute network. This is all Eclipse ioFog, all available open source from Eclipse, so go ahead and try it. And then it also has integration with Kubernetes, because if you already have a backend, which is 95% of people out there, right, have a backend in place already, very few things are completely greenfield, then you want to integrate with what you've already got. You can use Kubernetes optionally. You don't have to. So it's your choice with ioFog. And so then your life cycle is you've got developer tools that look just like your regular developer tools. We really try to make sure that you don't need new skills here. But then you need an environment, and that's where you have to install ioFog, like ioFog local, ECN, as you know from the hackathon, right? Installing it and getting up and running. You basically have an edge environment right on your laptop. Then you can connect to local devices and work with them. But then when you go to production, EdgeOps tools begin, and that's where you do a deploy, and you can say, well, I'm actually going to show you some of the commands. It's basically ioFog CTL deploy from a file, where? And then it'll put it out there on that board. I can do that. I could be at home in Berkeley, California right now and turn on this camera in this room from there, as long as it's on my edge compute network that I own. But you couldn't do it because it won't let you. You don't have the authorization. And you're right here in the room. So it's pretty interesting stuff, right? All right, so just want to take a moment on this. How do you make money on top of open source in the edge computing world? It's early days, so there's going to be a lot of differences, but I know one thing for sure. Always open source should be a complete piece of infrastructure. It does nobody any good to have an open source platform that's missing key pieces. But on top of it, there's so much that you can do to make a business out of it. And that's what we do at Edgeworx. We do ioFog, Eclipse ioFog, and on top of it, we're beginning to make more and more commercial operation pieces of software. Just sit right on top of the open source. There's no reason that you can't add, a software as a service portal or extra security extensions for particular chip manufacturers, like Intel in this case. So there's a lot that can be done. You're not stuck saying, oh, it's an open source infrastructure, so there's no way to monetize. It's just early, so don't have good examples yet, other than companies like mine. So real world example. Let's take a look. So this is a telecommunications customer of ours based out of Japan. They have private LTE base stations. In fact, they make many models. One model gets mounted to the wall, and it's kind of big. Another one is in a cart that you can wheel around by hand. And that's for like police and firefighters and military, and it's for people that go into disaster locations and set up temporary cell systems in order to provide aid. These are really cool units. And that's actually the screenshot I'm going to show is running on a private LTE base station like that. So what do they do for edge computing? Well, they've got all of their usual backend stuff, central data, and some place to monitor the system. But at the cell tower, they need to do the processing, even if it's a mini cell tower. And then you have actual cameras and vehicles, and then biosigns and wearable cameras going through smartphones that all need to talk to it. And if the data doesn't have to go back to the cloud, then the capacity of your edge system is based on just how many devices per base station. And then you do the math and you say, oh, we need 5 base stations to cover the entire city of Berlin, for example, based on the spread and the bandwidth. And then your math is done. There's no problem with backhaul. It all stays local. And so this is what it looks like, the user interface for it. And obviously you can see the company is Japan Radio Corp. So you have a wearable cam that goes out in the field. In this case, it would be 3 currently offline cameras and 1 online, but 4 total. And as the people go out and look at things, detections are made by the AI right on the base station. No cloud. And the detections are then piped back to the other smartphone users saying, here's where the person saw it, here's what they saw, the identified objects, person and motorcycle, and then you can watch the video of what was detected. All right on the edge, no cloud at all. This is amazing because it means that in a disaster scenario, you actually have advanced technology at a time when people can't even get a text message through. So your whole team goes out with wearable cameras. They don't even need to point at anything. They just do their job. And if something goes on fire in the background, everybody knows where and when and has a video clip of it before you even get the phone out of your pocket as a firefighter or as an ambulance driver, whatever. It's really cool stuff. So a little diagram of it. they used this module from NVIDIA called the NVIDIA Jetson Xavier, which is a fairly powerful edge GPU board. And there's several microservices running inside there, so multi-microservices to make the solution. And then the smartphones are able to talk to that unit over the LTE cell signal. And the round trip looks a little something like this. The smartphone sends in an image, it goes to the AI. The AI then changes what's called the command microservice that talks to smartphones and updates this thing that is the edge intelligence about, like, well, what image resolution can I ask for on the edge given how many phones we've got online and how many videos are currently being streamed and so on. So it actually measures what's going on in the network to adjust dynamically. And if your smartphone is not currently in a danger area, then it'll tune you down and say, yeah, lower your resolution, please. Like, you're not a big deal at the moment. And so the command microservice is talking to all the phones and doing that. So it's a really dynamic engine that keeps the edge running optimally. Because normally we just care about, I've got a cell connection, I'll send as much as I can, as fast as I can to the cloud, and we'll let the cloud deal with it. And that's fine if you can afford to wait, a few seconds for something to come back, or you want to pay a ton of dollars to send the video up from every camera. But it doesn't work in a scenario like this, and it doesn't work if you want it to be cost effective. Video will cost you a ton of money if you just endlessly stream it, right? And so on a cell, especially on cellular, right? On cellular, it is 2 gigabytes per hour for constantly streaming HD video per camera. So if you've got 20 workers in the field, we're talking 40 gigabytes per hour. Okay, oh, really, 5 minutes, all right, okay. I guess we might not look at code. Let's just look at the thing operate for fun, and I can take questions. Shoot, time flies. Okay, this will take just a moment to get out of the presentation mode. So let's see here. This is ECN Viewer, which is showing the edge compute network that I have set up where I have my control plane in the cloud. I'm gonna power on this Raspberry Pi, and it has an Intel Neural Compute Stick 2 attached to it via USB. So that's going to speed up the processing capability, although the CPU is the Raspberry Pi CPU. And right now, this unit is gray because I'm just powering it on, and it's just coming online. As you can see, I have one agent in the United States on the East Coast that's not running any microservices right now. It says 0. My controller is this purple one, also on the East Coast. It's actually running in Google Cloud. And then the gray one here is here in Germany, which got detected when I added this thing. And then as soon as it's done booting up and reports in, then we'll have the unit go green, and it will should list again that there's 0 microservices running, because I'm not currently running anything. And so to run the solution, I'm actually going to go and do the deploy. Let's see, let me make sure I'm in the right. Oh, perfect. Yeah, I'm right here. So I have an application here that is the demonstration application, which is similar to what Japan Radio Corp is doing. It's just one little piece of it, which is the image recognition. And you use a YAML file to define an application in the Eclipse ioFog world, which is very similar to what you do in Kubernetes and other systems. And so there are 2 microservices that are going to run on this Raspberry Pi to make the solution. And let's see if we are live yet. It looks like no, not yet. And let me make sure that this thing is on. It is on. And I'll just check my network to make sure. Okay, yes, it says wired clients 1, and it's at IP address 102. So it'll come green any moment. And so while we wait for that status, I'll go ahead and do the deploy. Actually, you know what I'll do? I'll actually show you what's on the Raspberry Pi. Now, known host. Okay, so on the Raspberry Pi, I can do ioFog agent status. ioFog agent not running. That's interesting. Let's reboot that guy. Cool. We'll give it a moment to reboot, and then maybe that's why it didn't come online. That's always how a demonstration goes. So, one moment. I thought about, should I have it up? But I was like, no, I'll turn it on and I'll watch it go green, and that'll be really cool during the presentation. What a mistake. But also, to be fair, I couldn't have powered it up any earlier. And so while that reboots real quick, I'll show you some details of one that is online. So you click, you get where it is on the map, and you get all this information about what's happening on the board. Latitude, longitude, how long has the daemon been running, any security violations according to our policy, what's its local and external IP address, how's it talking to Docker, what version is it, and how much RAM is currently used, and CPU is currently used, there we go, and all kinds of cool stuff. It's very nice. Okay, that went green. Who knows why it didn't on first boot? I have no idea. Here it is, so let's go ahead and look at the whole edge compute network. There we are. And now I'll go ahead and do the deploy, and that's this easy. Well, actually, hold on. Let me first check. Let me cat that config. Yes, it's going to the right agent. I don't want to deploy it to the wrong board. And then I also, no, that's all I need to do. Okay, great. So then I have this beautiful command system, ioFog CTL, and I'll show you what an edge compute network looks like from the command line perspective. Same stuff that I got in the UI, right? How's my controller doing? Connector is this thing that provides the edge compute network that I mentioned, then my couple of agents, and then no applications running. So now I'll do ioFog CTL deploy application -f config YAML, and then in what namespace? The Eclipse Con Europe number 4. Deploying application, deploying, deployed. 2 agents, 2 microservices, couple of blue boxes because it pushed it out to this one right here in the room. It should show number 2 as soon as it's done starting them up, but right now they're going to be listed as like queued, and then starting, and then running. And as soon as they're up and running, this camera is going to get a red dot on it, red LED, showing that it's live, and I'm going to point it at you all for fun. And what's going to happen is the 2 microservices, one of them captures the video from the camera and does some AI object recognition on it, and then passes on the data. So it has no awareness of how that information will be used, but it takes a picture, labels everything in it, draws the boxes around it, and sends it on. Any application can digest that. And then we pass it to a UI application. Oh, great. Pass it to a UI application that shows what's running, and that would be at 192.168.1.102, and I just got the stop signal, but we'll be able to get this up and show you. It should be port 5050. No, but let me check in my YAML file. That says, 5005. Nope, Siri, I don't need your help with anything, ever. Okay. Fingers crossed. Here we go. Look at that. And that's what we got going on in the room. And let's look at our wonderful AV assistant here. And so it'll refresh every 1 second or so with new frames. There we go. It did identify you as a person, which is very good. Very good. So yeah, this is 8.5 frames per second of multi-object image recognition off of any camera source on a Raspberry Pi with a $100 Intel compute stick. So the whole solution here is costing about $140 US, uses less than 10 watts of power, can recognize a large number of objects, and then you send the data wherever you want, including nowhere. If you want to send it nowhere, you can do everything on the Pi like I'm doing. Or you can take the text that you find and send that to the cloud. So you're sending kilobytes instead of gigabytes. And I think we're out of time, but I'll stick around for questions, and I think we all got to go head to the closing. I'm glad I got to show that go live. I thought I'd have time to show the code, but it's really not much code either. So I guess that's it.